everybody. We're getting ready to do lesson 3.1, part 2 of pre-calculus math today. Email me here for course materials. Okay, hello everybody. We're getting ready to do 3.1 exponential functions and their graphs, part 2 today. We got 50 points here in our classwork lecture, and there's 2 points here that goes in your notebook. Again, contact me for note-taking guides. And our bell work teachers today is a library of parent functions here. Use the graph of f, here's f here, to describe the transformations that yields the graph of g. So from here to here, students describe the transformation, then sketch these graphs. Use these tables, students, to plot some points on there and then sketch it. And then describe the transformation. Use an extra sheet down here. You have some room here to describe. Up here for this one, students describe here what the shift is, the transformation of the graph. Teachers, give your students about 6-7 minutes for these. Okay, so we go to our solutions here. Teachers, give your students 6-7 minutes for this. This is our answer slide for our bell work today, library of parent functions. Use the graph of f. Use this graph here to describe the transformation of g. Down here, same thing. So to do that, for number 1 up here, we have 3/5 x. The graph of negative 3/5 x, this is our transformation here, is a reflection in the x-axis. So this is 3/5 x here, and then negative 3/5 x is a transformation of this graph. Has a horizontal shift of 4 units to the left, so we're shifting 4 units to the left, and it's a reflection in the x-axis. So we have this negative 3/5 x plus 4. This would be this graph here. And then down here, 0.3x is f, 0.3 to the x power, and then g of x is negative 0.3 to the x power plus 5. So the graph of negative 0.3x plus 5 is reflection in the x-axis. So it is reflection in the x-axis, and there's a shift here to the left of 5 units. So this is negative 0.3 to the x power plus 5. Here is our y-intercept here, and then down here, when x equals 0, y equals 1. So this is your shift here. And 5 units upwards. There's an upward shift here of 5. Vertical shift of 5 units upwards of 5. Actually, it's only shifted up it shifts up 5 here, but the y-intercept is at 4. Because when x equals 0, 0.3 to the 0 power is negative 1, plus 5 would be 4. So that, but this is definitely an upward shift, a vertical upward shift of 5. Okay, so in your notebook, slide number 1, 2 points here. This is your notebook slide. Either get your notebook or note-taking guide out for this. The natural base e, for many applications, the convenient choice for a base is the irrational number e, which equals 2.71828121828. This number is called the natural base. The function f of x equals e to the x is called the natural exponential function, and its graph is shown. So to show that, here is the natural e function here, graph. F of x equals e to the x. Here it is here. So 0, 1 is a common point. And then you have these others here when x equals negative 1, y equals 1 over e. So e to the negative 1, e to the negative 2, etc. And then up here when x equals 1, y equals e, which is 2.7, blah, blah, blah. The natural exponential function. The number e can be approximated by the expression 1 plus 1 over x to the x power. That is one way that the number e can be expressed. It's an equal expression. Okay, let's go right into an example 5, approximation of the number e. Here is our equal expression for that. For several large values of x, see what the values approach. See that the values approach this number here as x increases without bound. So here's our graphical solution. We start here, and then we have a horizontal asymptote here. y2 is e. So when we start here, it increases and it slowly approaches the line, the horizontal line here for e. As x increases, the graph of y1 gets closer and closer to the graph of the line y2 equals e. So, numerical solution. So if we put this into a graphing calculator, we can see that as x increases here to 6 digits here, 1e to 6 digits, we can see as 2.7183 is a round off there. So that is one way that we can verify that e equals this number here. Use table feature in your graphing calculator to bring up the screen here. Enter y1 equals here, so y1 is this expression here. And then it seems reasonable to conclude that 1 plus 1 over x to the x power approaches e as x approaches infinity. That would be one way, another way that you could express this number here. Okay, so we're going to go into our first example here of our guided practice. This guided practice, this is independent practice, students. This is yours. I'll do this one in the classroom. We need to show that the value of f of x as it approaches the value of g of x, as x increases without bound, a graphically and b numerically. So here's f here, 1 plus the quantity 2 over x, all of this to the x power, and then g of x is just e squared. So we'll have x and then y1 here and we're going to use a graphing calculator to show this. And then down here, students, this is yours, except you have e cubed, and then here you have a different quantity here. So you need to put this into your graphing calculator. So for our guided practice up here, this is what x will look like here. So when x equals 10, it would y would equal 6.1917. When x equals 100, 7.2446. And then when x equals 10,000, etc., etc. here. So it seems like we're tending to here, which is 7.389, which, by the way, is would be e squared here. So e squared would be 7.389. So this this would be, this line here tends to approach e squared as it progresses towards infinity for x. That would be what your graph should look like on your graphing calculator. So graphically and numerically, here's your numerical representation. As x goes in infinity, it approaches 7.389. Okay, so into our next example here. We're going to go into example 6, evaluate a natural exponential function. Use a calculator to evaluate the function f of x equals e to the x at each indicated value of x. So when x equals -2, e to the -2 power, that would be what it would look like, the function value. And then here would be your graphing calculator keystrokes for that. And then to evaluate each of the function. Okay, so we'll get to that. And then what you get there, e to the x to the -2, you should get your solution on your calculator. And then here, f of 0.25 would be e to the 0.25. That's really what it would look like. And then your graphing calculator entry would be e to the x 0.25, and then hit enter, and you'll get your solution there. And then for -0.4, f of -0.4, and then this is what it would look like, e to the negative, and it should be in parentheses here in your calculator. Well, they put the they do put the negative. Well, it's just -0.4. They really don't put it in parentheses. So if you're overly cautious, that's what you would do. So e to the x, and then -0.4, and then x equals 2/3. So again, f of 2/3 would be e to the 2/3, and this is how you would enter it. Here you would use parentheses here, open parentheses, 2 divided by 3, close parentheses, and hit enter, and then that would be your what you get from your calculator. So let's go into our next example here. Our guided practice here, and then our independent practice here. So when we go e to the x, and x is 9.2, what would that look like? Well, for that, we would at e to the 9.2, you should get 97.129. That should show up in your calculator if you're entering it correctly. And then for down here, enter that. You have a negative x, and then your x would be a -3/4. I would use parentheses here, students, for that one. Okay, on to our next example here. Example 7, graphing natural exponential functions. Sketch the graph of each natural exponential function. So f of x equals 2e to the 0.24x. So that would be your function. Your graph should look like this. It has a pretty gentle slope for that one. And then for g of x here, it would be 1/2 e to the -0.58. So this here is less than 1. That's why it's falling. It's a decreasing exponential like that. That's what that graph should look like. You should key that in during class, or if you're doing this online, you should key that in now and stop the video or the PowerPoint. And then here are the table. Here is the table. That should be on your calculator too. You should be able to access, go into your table, and then you should get these values here for your different entries for f of x and g of x. Okay, getting into our examples here for sketching the graph of these functions here. We have tables, and then we have a graph grid, and then we have a description box here to identify any asymptotes, put those in this box here. So let's do 47. S of t equals 2e to the 0.12t. Here is your table that you should get once you enter that into your y1 equals. Go to table, you should get this table here. And then here is your graph. After you hit graph, this is what your graph should look like. And then your asymptote would be y equals 0, which is your x-axis. So that would be your horizontal asymptote. And then over here, here's your table for g of x equals 1 plus e to the negative x. You should get this table here. And then here is your graph. So we have a graph here as a decreasing exponential here. And then your asymptote is y equals 1. So your horizontal asymptote will be y equals 1. So your graph will never cross that. It will come close, but it won't cross y equals 1. And that is your lesson for today. If you need note-taking guides, or if you need quizzes or tests or solution PowerPoints for homework and tests, email me at animatedpowerpointmathvideo@aol.com. Thank you very much.